Welcome, everybody. Thanks for joining us again here from the Cloud Lunch and Learn. Today, we have a really interesting session. It's going to be all about DevOps tools and technologies for cloud engineering. I have here with me Vladislav. He's ready to go to take over the show. And the plan is for us to stay here the next 45 minutes over those technologies. Vladislav, do you want to give a quick intro about you? And then in a few seconds, I will share your screen and then you can take over the show.
Hello everyone. My name is Vladislav Bilay and I'm Cloud DevOps Engineer. The topic of this lecture is DevOps tools and technologies for cloud engineering, and I think it would be useful for every DevOps and system administrator.
Okay, great. Yeah, I was talking to Vladislav, and the plan is to, if you have any questions, please just type on the chat box, and then he will tackle those questions at the end of the presentation. He just want to make sure, there are some key elements to be tackled before. And please remember, this session will be recorded and available on YouTube, and then you can go back and, watch how many times do you want. Okay, great. Let me share your screen. Your screen is there. That's it for me for now, Vladislav. You can take over now, and I will be here on the background if you need anything from me, and then we can talk at any time, and we will tackle the questions at the end of the presentation then. Okay, the floor is yours.
Thank you, Jackson. So, hello again. The session focuses on the tools and technologies used in DevOps practices for cloud engineering. I will provide an overview of essential tools and technologies that enables automation and collaboration of cloud infrastructure and applications. You will gain insight into the DevOps tools landscape and explore the potential for integrating these tools in their own cloud engineering workflows. DevOps started as a way to solve problems caused by old-fashioned software development methods. Initially, its focus was narrow, revolving around two key components. Continuous integrations highlighted the automations of code integrations, ensuring that code changes from multiple developers could be seamlessly integrated into the project without conflicts. Continuous deployment extended continuous integrations by automating the deployment process and simplifying swift and reliable software releases. DevOps extended its scope over time as organizations adopted DevOps practices and noticed their transformational potential. It grew to contain a more comprehensive set of principles and practices, including automation and orchestration. DevOps highlights the importance of automating recurring tasks and the orchestration of complex workflows, reducing human error and enhancing operational efficiency. Collaboration and communications. The cornerstone of DevOps shifted towards fostering collaborations and communications among cross-functional teams, cultivating a culture of shared responsibility and continuous improvement. Monitoring and feedback. By using real-time monitoring and feedback, organizations can quickly find and fix problems, making software delivery faster and better. So, as organizations increasingly adopt cloud computing and containerization technologies, the need for agile and scalable development and operations practices become crucial. DevOps plays a pivotal role in enabling cloud-native development and operations in the following ways. First, microservices and containers. DevOps is essential for implementing microservices and containers. It simplifies the creation, deployment, and scaling of containerized applications, aligning perfectly with requirements of cloud-native architectures. Also, DevOps champions the use of infrastructure as code, allowing teams to define a previous infrastructure through code, ensuring consistency and scalability in cloud-native environments. Scalability and resilience. DevOps practices such as automated scaling and proactive monitoring empower applications to scale dynamically and maintain high availability in cloud-native ecosystems. And the last one is DevSecOps. Security is critical in cloud-native environments, and DevOps extends its reach to embrace DevSecOps. Integrating security practices into development and deployment pipelines to ensure the safety of cloud-native applications. In the ever-evolving landscape of software development, cloud-native DevOps has appeared as a transformative approach that leverages cloud technologies to streamline development, deployment, and management processes. To truly get cloud-native DevOps, you need the right set of tools that not only simplify but also enhance your workflow. Now we will explore some of the best and most unique tools. So first, it's Kubernetes. Kubernetes is a very important and popular tool. It is an open source platform for automating the management of containerized applications. It simplifies deployment, scaling, and maintenance, making applications more resilient and scalable. Kubernetes organizes containers into pods, provides self-healing, and enable rolling updates. It is cloud agnostic, supports custom extensions, and it's essential for modern, efficient applications management. Also, Kubernetes seamlessly integrates with a wide range of complementary tools and services. The next one is Docker. Using Docker in a cloud-native DevOps environment is a common and practical approach. Docker is well suited for containerization, which aligns with the cloud-native principles of scalability, portability, and resource efficiency. Integrating Docker into your cloud-native DevOps workflow is a pivotal step towards achieving a streamlined and efficient development and deployment process. Containerizing your applications with Docker enables portability, scalability, and consistency across different environments. Storing Docker image in a container registry enables version control and accessibility. Setting up development environments with Docker ensures that developers work in environments mirroring production, and improving collaborations. Incorporating Docker into your CI/CD pipelines enables automated tests and deployment, improving the reliability and speed of your software delivery. Finally, Docker empowers your organization to embrace cloud-native principles and effectively manage and scale cloud-native applications. The next one is Prometheus and Grafana. This monitoring tool is essential for maintaining visibility into your cloud-native applications. Prometheus collects metrics from various components, while Grafana provides visualization and alerting capabilities. Their integrations allows you to create custom dashboards and gain deep insight into your system performance. For example, deploy Prometheus and Grafana within your Kubernetes cluster to monitor containerized applications. Configure Prometheus to scrape metrics from your services, and use Grafana dashboards to visualize performance data. Integrate alerting to receive notifications when anomalies occur, ensuring proactive incident response. So now Helm. Helm is a package manager for Kubernetes that simplifies the deployment of applications via customizable charts. It helps in version control, rollback, and sharing of Kubernetes applications, reducing deployment complexity and enhancing DevOps workflows. For example, standardize applications deployment by using Helm charts to package microservices. Store these charts in a version controlled Git repository. As part of your CI/CD pipeline, Helm deploys charts to Kubernetes clusters automatically, promoting consistency across environments. So now Spinnaker. Spinnaker is a multi-cloud continuous delivery platform that excels in management complex deployment pipelines. It integrates seamlessly with Kubernetes, making it a powerful tool for cloud-native DevOps engineering who operate across multiple cloud providers. For example, suppose you're managing applications across AWS and Azure, and integrate Spinnaker to create a unified development pipeline. Spinnaker's cloud provider integrations allow you to deploy and manage your applications consistently on multiple cloud platforms. Istio. Istio is a service mesh that provides advanced networking, load balancing, and security features for microservices in Kubernetes environments. It ensures seamless communication between services and help with traffic management, security, and observability. For example, implement Istio as a service mesh within your Kubernetes cluster. It automatically handles service-to-service communication, provides security features like mutual TLS, and enables traffic management with features such as canary deployment and alpha-beta testing. Native. Native is an open source platform for building, deploying, and managing serverless workloads in Kubernetes. It enables cloud-native DevOps teams to leverage the benefits of serverless computing while maintaining the flexibility and control of Kubernetes. For example, extend your Kubernetes cluster with Native to run serverless workloads and integrate Native serving to automatically scale your application based on incoming requests, reducing operational overhead and cost. The next one is DevOps. DevOps is a powerful approach to managing infrastructure as code using Git repository. Tools like Argo CD enable automatic synchronization between your Git repository and your Kubernetes cluster, simplifying deployment and configurations management. For example, establish DevOps workflows by configuring Argo CD to synchronize your Kubernetes cluster with Git repository containing infrastructure and application manifest. Every code change triggers Argo CD to apply updates, ensuring a Git-centric and automated approach to managing your cluster. So now, house engineering tools. House engineering is a unique approach that helps you proactively identify weaknesses in your cloud-native applications. Tools like House Monkey simulate failures in your system to test its resilience and help you build more powerful applications. For example, integrate House Monkey into your cloud engineering workflows to periodically inject failures into your infrastructure and applications. Use, for example, AWS Lambda or Azure functions to run House Monkey function on a schedule, helping you proactively identify and address system weaknesses. Now, Kubeflow. For organization focuses on machine learning and data science in their cloud-native DevOps. Kubeflow provides a platform for building, deploying, and managing machine learning pipelines and models on Kubernetes. For example, if you are developing machine learning models, integrate Kubeflow into your workflow. And Kubeflow pipelines allows you to create and manage machine learning workflows on Kubernetes, ensuring reproducibility and scalability for your data science team. The next one is serverless frameworks. Serverless computing complements cloud-native DevOps by allowing developers to focus on code without managing infrastructure. Cloud providers offer serverless platforms like AWS Lambda and Azure Functions that can simplify the deployment of event-driven applications. For example, embrace serverless computing by integrating AWS Lambda or Azure Function into your application architecture. Trigger serverless function in response to event like HTTP request, database changes, or file uploads, allowing you to expand seamlessly based on demand. Integrating these cutting-edge tools into your cloud engineering workflows is essential for achieving cloud-native DevOps ability. Whether you're managing containers, monitoring applications, automating deployments, or ensuring security and resilience, these tools enhance your capabilities and efficiency in the cloud-native ecosystem. By customizing their integration to suit your specific use cases, you will be better equipped to meet the challenges of modern software development in the cloud. As organizations aim to deliver software faster, safer, and more efficiently, they turn to advanced CI/CD strategies. Let's explore advanced CI/CD strategies with real-world examples. First is blue-green deployment. Blue-green deployments involve running two identical environments, blue and green. The blue environments represent the current live version of your applications, while the green one is where you deploy updates. The idea is to switch traffic instantly from blue to green, or vice versa, to minimize downtime and rollback in case of issues. Netflix is a prime example of using blue-green deployment. They employ this strategy to push updates to their streaming service without impacting user experience. If a problem areas in the green environment, they can quickly switch back to blue, ensuring uninterrupted service for their users. The next one is canary releases. Canary releases are all about testing new features or updates with a small group of users before rolling them out to everyone. This strategy allows organizations to gather real-world feedback and detect issues early. Google Chrome Canary versions is a classic example. It is bleeding edge release channel for the browser, intended for developers and fans. Google uses it to experiment with new features and collect user feedback before incorporating them into the stable version, ensuring a smoother user experience for the wider user base. Feature flags. Feature flags, also known as feature toggles, enable you to control the release of features by toggling them on or off without code changes. They provide flexibility for alpha beta testing, push and rollout, and quick hotfixes. Launch Darkly is a dedicated feature flag management platform. Organizations like Atlassian and Microsoft use it to release new features selectively, monitor their performance, and make data-driven decisions about whether to keep, improve, or disable them. The next one is DevOps. DevOps is an approach where all CI/CD pipelines configurations, including infrastructure and applications code, are stored in a Git repository. Changes to repository treat automated actions, maintaining a declarative state of the entire system. Weaveworks, a Kubernetes-based company, champions DevOps principles. They use tools like Flags and Argo CD to manage Kubernetes cluster. Changes made to the Git repository, such as updates to Kubernetes manifest or application code, are automatically synchronized with the live environment, promoting consistency and reliability. The next one is immutable infrastructure. Immutable infrastructure treats service and infrastructure components as disposable. Instead of modifying existing servers, you create new ones with every change. This approach reduces this risk of configuration creep and simplifies rollback. AWS uses this approach with services like AWS Elastic Beanstalk, where updates result in the creation of new environments, preserving the existing one for rollback. This ensures a consistent and predictable infrastructure state. The next one is serverless CI/CD. Serverless CI/CD leverages serverless computing to scale CI/CD processes dynamically. You only pay for what you use, and you can run, test, and deploy function in a serverless environment. The serverless framework is a prime example of this strategy. It allows developers to deploy serverless applications effortlessly, running tests and deploying updates on a serverless platform like AWS Lambda and Azure Function. Whether it's blue-green deployments, canary releases, feature flags, DevOps, immutable infrastructure, or serverless CI/CD, these techniques are essential tools in the modern software development toolkit. By incorporating them, you can achieve higher velocity, enhancing quality, and happier users. Containerizations offers multiple benefits, such as improved scalability, portability, and resource efficiency. However, as organizations scale up their containers infrastructure, managing and orchestrating these containers become more complicated. There is where advanced container orchestration comes into play. Let's explore the concept of advanced container orchestrations, its significance, and some of the leading technologies. First is multi-cluster orchestrations. Advanced container orchestrations extend beyond a single cluster. It involves managing multiple clusters, often across different cloud providers or on-premises data centers. Tools like Kubernetes Federations, Google Answers, or HashiCorp Nomad enable seamless multi-cluster management. For example, let's consider real-time e-commerce platform that helps customers worldwide. To ensure low latency and high availability, they deploy their containerized applications across multiple clusters in different regions using Kubernetes Federation. This allows them to manage and scale their applications globally from a centralized control plane. The next one is high availability. Ensuring continuous availability is crucial for mission-critical applications. Advanced orchestration solutions incorporate strategies like multi-zone deployments, automatic failover, and cluster scaling to guarantee high availability. Suppose a financial institution is running a microservices-based trading platform. To ensure uninterrupted services, they deploy their applications on Kubernetes with multi-zone support. In the event of zone failover, Kubernetes automatically redirect traffic to healthy containers in other zone, maintaining high availability. The next one is resource optimization. Efficiently using resource is a significant concern, especially in large-scale deployments. Advanced orchestration tools employ techniques like bin packing, vertical and horizontal autoscaling, and resource quotes to optimize resource usage and reduce costs. Consider a cloud-based video streaming service. During high usage hours, the service autoscales horizontally by adding more containers instances to handle increased traffic. When traffic decreases, it scales down to save cost. This dynamic resource management is achieved using Kubernetes horizontal pod autoscaler. And the last one is security. Container security remains a major concern. Advanced orchestration solutions provide features such as pod level networking policies, role-based access control, and image scanning to enhance container security. In healthcare applications storing sensitive patient data, Kubernetes role-based access control is employed to restrict access to specific containers. Additionally, container images undergo continuous vulnerability scanning to ensure that only secure images are deployed. Kubernetes, as I said before, Kubernetes is the de facto standard for container orchestrations and has evolved to meet the demands of advanced use cases. Features like multi-cluster management and cluster API enable multi-cluster orchestrations. For instance, a large e-commerce platform uses Kubernetes to manage multiple clusters across different cloud providers, including AWS, Azure, and GCP. They achieve this using Kubernetes Federations, which provides centralized control and visibility across these clusters. HashiCorp Nomad. Nomad is designed for simplicity and scalability. It excels at managing large clusters and supports multi-data centers deployments. A global gaming company deploys its game service using Nomad. Nomad's multi-data center supports allows them to host game service in data centers worldwide, ensuring low latency for players. The next one is Amazon EKS Anywhere. Amazon Elastic Container Services now extends its capability to on-premises and edge environments, making it compelling options for hybrid cloud deployments. A manufacturing company use EKS Anywhere to manage containers on factory floors and in their data centers. This allows them to maintain a consistent containerized infrastructure across all locations. Google Attendees. Attendees provides a unified platform for managing containers across different cloud providers and on-premises data center. It offers advanced capability for multi-cluster and multi-cloud registrations. Finally, a financial institution adopts Google Answers to deploy its applications across multiple cloud providers, ensuring redundancy and cost optimization. And this consistent management plan simplifies its operations. Infrastructure as code. Infrastructure as code revolutionizes infrastructure management by iterating its code. Using tools like Terraform or AWS CloudFormation, organization can define, configure, and automate infrastructure deployments. In the context of an e-commerce platform, infrastructure as code ensures scalability and consistency across Kubernetes clusters. With infrastructure as code, organization declares their desired infrastructure in code, store it in version control for collaboration, and use automations to provision resources. Replicating clusters across regions is simplifying, and CI/CD integrations streamlines infrastructure changes with code updates. Monitoring security, compliance, and scalability are seamlessly integrated in the process. In nature, infrastructure as code aligned with cloud-native DevOps principles, accelerating the deployment and management of Kubernetes clusters, and enabling organizations to deliver reliable and scalable applications across version environment. Service mesh integrations. Implementing a service mesh like Easter or Linker can improve network security, observability, and traffic management in complex deployments. In microservices-based travel booking platform, Easter is employed to manage traffic routing, enforce security policies, and collect telemetry data. This ensures soft communications between services and enhance overall reliability. CI/CD integration. Integrating CI/CD with container orchestration such as Jenkins and Kubernetes is a transformative practice in modern software development. In this step, developers push code changes to version control, triggering a series of automated processes. Jenkins orchestrates the build, testing, and deployment of containerized applications to Kubernetes cluster. These integrations enhance development workflows by automating repetitive tasks and ensuring consistent, reliable deployments. Developers focus on writing code, while Jenkins takes care of building containers, running tests, and deploying updates seamlessly. Kubernetes handles rolling updates and scaling based on resource demands. The CI/CD pipeline serves as feedback loop, allowing for quick identification and resolutions of issues. Overall, this integrations accelerates time to market, reduces errors, and align with cloud-native DevOps principles, driving efficiency and innovations in software development. Monitoring and loading. Implementing robust monitoring and loading solutions, such as Prometheus, Grafana, and the Elasticsearch Logstation Kibana stack, is a great practice in cloud-native environments. These tools provides organizations with invaluable insight into the performance, health, and security of their containerized applications and infrastructure. In a real-world scenario, an e-commerce platform built on Kubernetes leverages these tools to collect and analyze metrics, visualize data through custom dashboards, and centralized log. This integrations not only aids in troubleshooting and performance optimizations, but also supports compliance and security efforts. By tightly integrating monitoring and logging into CI/CD pipelines, the platform ensures that every application's version is instrumented from the start. This proactive approach enables continuous improvement with actionable feedback from logs and metrics informing development and operational teams. Backup and disaster recovery. Implementing backup and disaster recovery plans for containerized workloads is essential for covering critical data and applications. In healthcare, where patient data integrity is important, tools like Velero employed to ensure data recovery in the face to unexpected failures and data corruption. Velero seamlessly integrates with Kubernetes environment, capturing regular snapshots of cluster states, including sensitive patient data. These backups are scheduled and incremental, optimizing resource usage and ensuring data consistency. Cross-cluster replications and encryptions further enhance data resilience and security. A well-defined disaster recovery plan outlines procedures for swift and automated data restoration, minimize downtime and data loss in case of adverse events. Regular testing ensures plan points, ensuring the reliability and availability of patient data. So, advanced container orchestration is a condition as organizations scale up their container-side infrastructure and adopt multi-cluster, multi-cloud, and hybrid cloud strategies. It addresses the challenges of managing complex container deployments, ensuring high availability, optimizing resource, and enhancing security. By leveraging advanced container orchestration technologies and best practices, you can unlock the full potential of containerization while maintaining agility, reliability, and security in their application deployment. In conclusion, DevOps tools and engineering practices have become essential in the world of software development and IT operations. They represent a transformative approach to building, deploying, and maintaining software that emphasizes collaborations, automations, and continuous improvement. DevOps tools provide the necessary automation and visibility to streamline workflows, reducing manual errors, and accelerate the delivery of high availability software. In today's digital landscape, organizations that adopt DevOps tools and engineering practices are better positioned to avoid remain competitive and respond quickly to market demands. By adopting a DevOps mindset, leveraging the right tools, and fostering a collaborative culture, businesses can deliver software with higher quality, reliability, and speed. Finally, leading to improved customer satisfaction and business success. So if you have some additional question about this presentation and this topic, you can write me on LinkedIn and feel free to ask me. Thank you for your attention.
Okay, thanks very much for, oh my goodness, that was quite a lot of information and so many tools people can use. And of course, probably need to select whatever is more suitable for their environment. And yeah, anyway, the good thing, as I said before, this presentation will be recorded and available on our YouTube channel. And then you guys can go back and play as many times as needed. Yeah, just checking here. Yeah, we haven't got any question. And yeah, I think from now is all good, unless maybe we can wait 1 minute if anybody wants to ask something, and then we can close the presentation. Yeah, just getting a few. Thank you. That's great. Thanks very much for the all the information around those slides. That's great. Okay, I would say that's it for now, and please follow us on LinkedIn, on LinkedIn and Twitter as well, for just to be engaged and get to know what are the presentations on the horizons we will be here, presenting for the community. Okay, thanks again for the last hour or the last, good slides you presented. And thanks everybody from home watching us, and see you on the next presentation. Have a good day. Thank you.
Thank you. Bye.